Hey everyone, this is lesson 2.6, Transforming Linear Functions. These problems can be found on pages 134 through 137 in your Algebra 2 textbook. The objectives for today, you will learn to transform linear functions and you will be able to solve problems including linear transformations. So let's get started. So far you've learned to transform functions by transforming each point. And what I mean by that is if we had a t-graph or t-chart, and we had an x and y, so let's say that was 0, 1, 2, and this was 2, 4, and 6. And it said you wanted to do a vertical compression. We would keep all of our x's the same and just the y, because the y is our vertical component, would change. Say multiply each component by 2 or something. And the same if we asked for a horizontal shift, all of our x's would change, but all of our y's would stay the same. So that was, we could see it pretty easily. And now we're going to learn how to just do it, write it mathematically. Today you will learn that transformations can also be expressed by using function notation. So we're going to be learning about function notation. So we're going to start out with this chart here, and I'm going to go ahead and change it to a different view so that we can take advantage of some of the things on here. We're going to talk about the horizontal shift first, okay? So that's a translation, and the horizontal shift is simply when you take your graph, in this case it's a line, and it just shifts over to the left or the right. All right, but the y components stay the same. The x's, the horizontal part, is the only thing that's just shifting. And in this particular case, it shifted over to the right a couple of units. All right, so what that's going to look like is, and this is where it gets kind of tricky. So this line, we're going to just call it f of x, is going to change. Our new line is going to change. And that what's going to happen is our f, and inside, since our x is what changed, in this case it shifted to the right, so it actually is a subtraction, and we're just going to call that by h amount. All right, so in order to get our graph to have a horizontal shift, we take our x, because that's what's changing, and subtract it. In this case, if we wanted to go right, and if we wanted to go left, we would add by h amount, whatever that would happen to be. All right. So if we want to shift something vertically, then the graph is just simply going to move up or down. The x components remain the same this time, but the y components are changing. All right, so we keep our x's stay the same and our y component changes. All right, so if our y component is changing, remember we said that f of x is the same as y. So in this case, you have to take the whole f of x. All right, and in this case, we moved up, so we're going to add, and I'll just call that letter k, some amount k. All right, so this part that's a little bit tricky on here is when we're adding with y. If you add y, here's the rule, add to y, you're going to go high. All right, so when we add to y, it's going to move up. Add to y, go high. The thing that's odd about this that we have to remember, when we add to x, we actually go left. So our new picture, our new transformation would go left. And that's why over here where it's subtracted, when we subtracted, we actually went right. All right. And notice where our parentheses, in this case, when we're dealing with our x, we keep x and its transformation in parentheses together. When we are dealing with our y, we keep our y together and then we add or subtract to it. And this is going to be a shift, either up or down or left and right. So add to y, go add to y, go high. add to left, add to x, go left. All right, let's talk about our reflections across the y-axis. So when something reflects across the y-axis, the x's are going to be the exact opposite of each other, but the y is going to be the exact same. So I can just do a little sample of that over here. Our x's are going to become opposite, but the y's will stay the same. So let's just watch that happen. Okay. So there our x's became opposite, but the y's stayed the same. Okay, so let's just draw that. What happened here? We went that way. And again, our x's is what changed. So this was f of x, and it changed. The x changed. So how we're going to write that is say f of opposite of x. And notice that stays connected with our x inside the parentheses. All right, our last one that we're going to do is a reflection across the x-axis. So what's going to happen here, our x component is going to be the same, but our y component is going to change this time. So let's draw a reflection across our y-axis, and we can do that. The y is going to be what's changing here. So you can see it changing. The y is changing, but the x's are staying the exact same, and the y is going exactly opposite. So the way that we're going to write this now is f of x is going to be translated, or reflected, I'm sorry. Now, the y is what's exactly opposite. And remember, f of x is y, so we're going to say opposite of f of x. In other words, opposite of the y. So our new line is going to have everything the same, but the y's are going to be exactly opposite. All right, so where you add or subtract and where it is with the parentheses is going to make a big difference in what the translation or the reflection is. All right, if you have it inside with our x inside the parentheses, that means it's going to be horizontal. All right, horizontal or across the y-axis. If it's the y that's getting changed, it's going to be outside of it's not going to be just with our x, but our entire y function is going to be what's changing. All right, I know that's pretty tricky, and we're going to be doing more of those in class, so let's just keep on moving on with this. Okay, so let's give one a try here. So we're going to translate. It says, let g of x be the indicated transformation of f of x, and write the rule for g of x. So our ultimate goal is to be able to write g of x equals something. That will be our new line. So first of all, we're going to take our f of x, which is 2x plus 3, and we're going to do a vertical translation 4 units up. Okay, so remember we said add to y, go high. In other words, your line or whatever your graph is going to go high. If you add to x, your graph is going to go left. All right, so in this case, it says vertical, so that means it's going to be y, and it says to go 4 units up. That's high, so we're going to add. Add to y, we're going to go 4 units up. So we're adding to our y. So we're going to say, remind ourselves that f of x, which is the same as y, is equal to 2x plus 3. So we're going to have to add 4 units to this entire piece. All right, so we know that g of x is going to be the same as, or translated, f of x plus 4. All right, so that's y plus 4. So our equation is going to be g of x is equal to f of x is 2x plus 3 plus 4. All right, so g of x, when we add our like terms, equals 2x plus 7. So we can graph this. You can put this on your graphing calculator. I can graph it really quick here, and we can just see that it actually happens. So this is written in y equals mx plus b. So our y-intercept is 3. And our slope is 2 over 1, rise over run. So we're going to rise 2, run 1, rise 2, run 1. Rise, go the other way. And here's our line. Okay, now this is f of x. And now we're going to look at g. And g says start at 7. The y-intercept is 7. 1, 2, here's 7 right there. And again, our slope is 2 over 1. 1, 2. There we go. And let's see, did I do something wrong there? I'm not sure. These should be parallel to each other. Okay, so it should be 4 spaces up. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Everywhere should be 4. This one's a little bit off. 1, whoops. Let's see, 1, 2, 3, 4. All right, so, and that's 4 units up. All right, so that's what we have to do to write our new rule for G. And the answer that I'm really most concerned about is this right here, the G of x equals 2x plus 7. All right, let's try another one. Let G of x be the indicated transformation of f of x and write the rule for G of x. So same instructions. We're going to take the linear function defined in the table, so we'll have to write that out, and reflect it across the y-axis. So first of all, we have to figure out what is the equation or the rule for f of x on this problem. All right, so let's just figure that out. Well, we know that rise over run is our slope, so let's figure that. Rise over, let's see. Okay, so slope is equal to rise over run. All right, and our rise is 0 plus 2 is 2, and 2 plus 4, or 2 plus 2 is 4. So our rise is going to be 2. And our run, that looks like plus 1 and 0 plus 1. So our run is 1. So our slope is going to be 2. And remember, our y-intercept is what is y when x is 0? Well, x is 0, y is 2. So we know that b is going to be 2. So the equation for f of x, the one that we have right now, f of x is equal to 2x plus 2. All right, so there's our first equation, and now we have to figure out what to do. It says we want to reflect across the y-axis, so that means we're going to start on this side and go to this side. That means our y's are going to stay the same. Our x's are going to be completely opposite. All right, so what we have to do is say g of x, our new line, is going to equal 2, and then it's going to have our x, which is completely opposite. And notice how I isolated our x together with what we needed to do, which was do the opposite, plus 2. All right, so now I can rewrite that. G of x is equal to negative 2x plus 2. I know this can be kind of tricky, so you have to really be focused on what you're doing on these problems. All right, and we could graph that out and you would see it, or you could put it in your graphing calculator, but we're not going to do that just in the interest of time. But the main thing I want you to know is that this is your new rule for g of x. All right, so that's what it looks like when it's reflected across the y-axis. All right, let's try another one. And this step 2, I already did that for you. All right, try this one on your own. It's kind of tricky. Put the video on pause for a minute. See if you can do this one, and then turn it back on, and we'll do it together. Okay, so this one says we want to translate 2 units right. All right, so let's talk about what that means. 2 units to the right. So that's the right is going to be horizontal. All right, and our x is the component that's responsible for our horizontal. So we're going to be talking about our x, and we want it to go right. Now let's remember that little jingle that I told you. Add to y, the graph goes high. Add to x, the graph goes left. But our instructions say that we want to go right. So we're not going to add to our x, we're going to subtract to get our x to go left. All right, so g of x is going to equal, let's talk about this, 3. All right, now we're going to deal with our x's. So our x, what we're going to do has to stay in parentheses with our x. So we're going to say 3x and then minus 2. Because we're going left, so we're going to say minus 2. And notice I keep my x in parentheses all together. And then plus 1. All right? So let's just talk for a minute about this. If it had said change this 2 units up, then we would have been dealing vertically, which is our y, and add to y, go high. So our new one would have been g of x. Okay, so we're having to add 2 to the y now. So our y is actually this whole piece right here, 3x plus 1. And we have to add 2 to get it to go up. So that is what our new formula, our new rule would be, and we would rewrite it equals 3x plus 3. So if our equation had, or our question had asked to do it vertically 2 units up, we would have to take the entire y, which is 3x plus 1, and add 2 to it. So this would be if it was this, and that's not in your book, but this is the answer that's in your book. But I wanted to show you both ways because I don't think your book's very clear on that. Okay, let's do the next one. It says a linear function defined in a table, which is right here, and reflected across the x-axis. Okay, so let's first of all figure out what our original function is, f of x. We're going to say, so we have -1 plus 1 is 0, 0 plus 1 is 1. 1 plus 1 is 2, 2 plus 1 is 3. So our rise over run, which is our slope, is equal to 1 over 1, which equals 1. All right, and remember, what is y when x is 0? That's our y-intercept. And in this case, y is 2. So b is going to be 2. So when we do y equals mx plus b, we can say y equals m, which is our slope, 1x plus b, which is our y-intercept, 2. All right, so f of x of this function right here, f of x is equal to x plus 2. All right, so let's think about what happens when we reflect across the x-axis. All right, so here's a point right here, and we're going to reflect it across the x-axis because this is our x here. So you have to think as if there was a mirror here. So the actual x stays the same. The y component is what's changing. So our y is changing. The y is changing when we reflect across the x. All right, so remember this whole component right here, this is y, so this is y, so the whole thing is going to have to change. So our new function is going to say f of x is going to equal, and when we reflect, we're just taking the opposite of what we had before. So the opposite of f of x. And f of x is equal to x plus 2, substituting. So the new function is g of x is equal to the opposite, or negative x plus 2. And this would have been what your answer would be. I know that's super confusing. So try and go back and listen to this again, or just pay really close in class. All right. So that was translations and reflections. Now we're going to talk about stretches and compressions. And just like before, when we talked about stretches and compressions, it's going to be by a factor. So now we're going to be multiplying, not adding and subtracting, because when we think of factors, we think of multiplication. All right, and again, it's going to tell us is horizontal or vertical. It's going to tell us what it is. All right, and then depending on what the size of the number is that we're stretching, that we're multiplying by, is going to determine whether it's a stretch or a compression. So really, we don't have to worry about the wording stretch or compression. We're more concerned about that we're multiplying by the x or multiplying by the y. Okay, so here is our first tricky part. When we do a horizontal stretch or compression by a factor of b, this is what happens. We start out with f of x, all right? And to have a change, a stretch or compression, all right, if it's horizontal, we're dealing with our x. So just like before, we're going to say f of, and the x is what's going to get the change. And so in this case, we're going to multiply. And here's where we have to be careful. 1 over b. So if it says it has a horizontal stretch by a factor of 1/3, then what this would look like is going to be f of x changes to be f of x times 1 over 1/3. All right, because this is the b, which is what they said it was going to be a factor by. Okay, so let me remind you on how to do a problem that says 1 over 1/3. All right, you may have remembered from elementary school when you were learning division, and if it had a problem that said, let's say, we'll just do this exact same problem, 1 divided by 1/3, you might have learned a little saying that said keep, switch, or keep, change, flip. Okay, so keep the first one, change the division to multiplication, and flip this one, 3 over 1, so then that would equal 3. Okay, so it's keep, change, flip. So this sign right here is just a division sign. Another way you might think of it is you could multiply the top and the bottom by 3 over 1. And again, that gives you the keep, change, flip, and you end up with 3. All right, so you're going to have to be looking at this pretty soon. But the main thing I want you to make sure you understand is that when it says it's going to be a horizontal stretch or compression by a factor of b, it's going to be, you take your x, because horizontal has to be with the x, and keep that in the parentheses, 1 over b. 1 over b. So make sure that you learn that, because it's pretty tricky, and I'll be the first one to tell you it's real tricky, and so let's try hard to remember that. Okay, so when you're doing a vertical stretch or compression, let's look at what happens to our f of x, how that changes. All right, fortunately, vertical is a lot more simple, I think. Okay, so it says by a factor of a. So if we're doing vertical by a factor of a, all we have to do is multiply a times our y, because vertical is y. And so all we have to do is multiply a times y, and y is actually our f of x. Okay, we'll do a sample on that one in just a minute. So this one, the vertical stretch and compression, as also with the vertical translation, is pretty easy. The horizontal is a little bit more challenging on both of them. So we want to remember it's 1 over b, and when we're doing the stretch, remember if you're adding, you have to go left. So those are two things that we're going to have to keep track of. All right, let's do an example of one. Here it says let g of x be a horizontal compression of f of x equals 2x minus 1 by a factor of 1/3. It says write the rule for g of x and graph the function. Okay, so let's see if we can do that together here. All right, so first of all, what we want to do is we're going to write g of x, because that's going to be our new line. All right, g of x is equal to, all right, so it's going to be equal to 2. Now we have to decide, is this in the y or the x that we're dealing with? And it says it's horizontal, so that means we're going to deal with the x. So when we deal with the x, remember it says by a factor of 1/3. Oh, there it is again. So just like before, it's going to be x times 1 over b, and b is 1/3 today. So times 1 over 1/1/3. We have to keep that with our x. All right, so let me get this back in here. See if I can, oops, there we go. Okay, we want this to be multiplied by our x. All right, and then we can go ahead and finish up the rest of our, let's see, the rest of our equation minus 1. All right, so let's deal with this. 1 over 1/3. It's the same as, multiply that on the bottom, you multiply that on the top, equals 3. So 2 times 3x minus 1, and all of that is g of x. All right, and now we can just multiply that 2, so g of x is equal to 6x minus 1. All right, so that is your actual equation. Now it says to also graph this function. So let's do this really quick. It says f of x is 2x minus 1. So our minus 1 is our y component, our y-intercept, and we're going to have a slope of positive 2 over 1. So let's just chart that really quick. We'll go down and down. All right, so here is our original, whoops, here's our original, we'll call this line F. Now our compressed line, which is going to be our g of x, we're going to say y is negative 1. So we're going to come all the way down here to y is negative 1, and our slope is now 6 over 1. So let's go 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And we'll go down this way. 1, 2, 3, 4, 5, 6 over 1. About there. So here, let's see if I can do that, is our compressed line, like this. And so this would be our G. Okay, so that's our example. Now, once you try one on your own, put your video on pause and give it a try. All right, let's see if we can do this one. This time, it says we have a vertical compression by a factor of 1/4. All right, so this time we're going to be dealing with our, with our y. So g of x is going to equal f of x times our factor of a, which is 1/4. All right, so g of x, we're going to just fill in, substitute. Instead of saying f of x, we're going to say 3x plus 2, but we're multiplying the whole thing by 1/4. All right, so when we multiply it, we actually don't even have to go any further than that. You could go on and say f of x equals 3/4 x plus 2 over 4, and that would be 3/4 x plus 1/2 equals g of x. I would accept this one just fine, or I would accept this one just fine. Either one of those I would do just fine. All right. In fact, your book only says this answer right here. So that would be your vertical compression of f of x. And notice, since I was doing y, I just did I multiplied 1/4 by the entire y. All right, I'm not going to plot that out for the interest of time. Okay, but talking about transformations, I just wanted to point out to you that there are transformations even in our lives today. Romans 12:12 says, "And do not be conformed to this world, but be transformed by the renewing of your mind, that you may prove what is that good and acceptable and perfect will of God." All right, so I just want to tell you, the thing I really want to point out about this is do not be conformed to this world. So this world is going to ask you to be a certain way and look a certain way and act a certain way, but the Bible teaches us to not be transformed by that, or not to be conformed to that way, but to be changed. And we can be changed when our mind is focused on God and learning about God and trying to know God better. So I just want to encourage you not to be conformed to this world, but be transformed, be changed by the renewing of your mind. And Romans 12:12 might be a really good thing for you to write down and to remember. You don't have to have that verse memorized, but you might want to take note that Romans 12:12 is one of my favorite verses. So if you want to write down Romans 12:12, that would be a great idea. All right, just a little thought for you. All right, so let's try one more time. Some of your problems are going to have to do with combining transformations of linear functions. So the book is going to ask us to do some problems, and we have to do them in the order that they tell us to do them in. And we're going to set up sorry. Let's just get going with it, and I'll show you what all we want to do. Okay, so first of all, it says let x be a vertical shift of f of x equals x down 2 units, followed by a vertical stretch by a factor of 5. Okay, so let's talk about this. First of all, we're going to do a vertical shift down. All right? So remember, our story said add to y, the graph goes high. All right, so add to y, the graph goes high, and we want to go down, so we're going to subtract from y. All right, so that's pretty easy to do. We're going to just start out, and we're going to subtract from y. And remember, f of x is y. So g of x is going to start out being f of x, which is our y, minus 2. And now we can just replace f of x with what it is equal, x. So let's say g of x is equal to, it says x minus 2. So this is our first vertical shift. That's all we had to do. Now next it says we want to do a vertical stretch by a factor. So remember that factor means multiply of 5. And we're in the y, and y isn't near as complicated. We can just multiply y by 5. So let's just use a substitute. Let's see. Let's use a temporary function. Let's just call this g of x. It's not really g of x yet because we haven't done everything. So let's just change its name to substitute x, and I'll say h of x was equal to x minus 2. All right, so our new line is going to be g of x, and we're going to take h of x, which is our substitute, h of x, which is y also, and we're going to multiply it by a factor of 5 times 5. Y is easy. It's only when we go by x that we have to do 1 over. Okay, so here we can substitute our g of x back into h of x, which is our substitute 1, which is x minus 2. So we're going to say g of x is equal to x minus 2 times 5. All right, so now we just have to distribute everything. So we say g of x is equal to 5x minus 10. And that is your answer. All right. So we had to do two different things, and I just made up a little substitute for g of x so I didn't get confused with all my g of x's, but it doesn't matter. You can just keep track of it how you can. All right, and there's one more for you to try on your own, so give this one a try. Turn your video on pause and then come back when you're ready. All right, so let's talk about this one. It's a lot more challenging because we have a vertical compression, which isn't going to be bad, by a factor of 1/2, and then we have to do a horizontal shift, 8 units left. Okay, so first of all is the compression. So we're going to multiply y by 1/2. So we start out, let's see here. Let the vertical compression of f of x, okay, and let's see here. I didn't actually write the problem down correctly, so let's do it right now. Let's, f of x equals x. F of x equals x. That's what it should have been on there. All right, so first of all, we're going to do a vertical compression. So our first step is going to say g of x is going to be, vertical is our y. So we have to take f of x, which is y, the whole thing, f of x, and it says a vertical compression, so that's going to be multiplied by 1/2. So let's substitute for f of x here, which we see is equal to x. So we're going to say g of x is equal to x times 1/2. So g of x so far is equal to 1/2 x. All right, so that's kind of tricky, but not too bad. So now we're just going to keep in mind that this is not really g of x yet, because now it says we want to do a horizontal shift, 8 units left. So now horizontal is our x. So let's remember our rule again. Add to, let's see. Okay, here's our rule. Add to y, the graph goes high. Add to x, the graph goes left. All right, so it says we want to go 8 units left. So we're going to add to our x. All right, so what we're going to do is we're going to say g of x is going to equal, and so what we're going to look at is over here is we're going to say, we're just going to deal with our x, all right? So we're going to have 1/2, and then we're going to put in parentheses x, and we want to go 8 units left, so we're going to add plus x. All right, and there's your rule for g of x. All right, so I know this is pretty tricky, and we're going to be doing a lot of these problems in class also, so really stay focused on what it is that's translating, what is compressing, whether it's the x or a y, and what the rules are for that. So here is your beautiful picture for the day. I hope you guys have a great day, and I will see you soon.